Good evening, my dear students. Welcome to IMS Gate Academy. Myself, Vipin Mishra, the lead mentor at IMS Gate Academy. I welcome you all in this Gate Score Booster series of IMS Gate Academy. So, this series is going to help you in a great manner because the last time preparation that you need, you can get from this particular series. As the gate exam is inching closer and closer day by day, so right now you must be wondering what all of the important topics, formulas and questions you should prepare in order to give a boost to your preparation. Okay, so because IMS Gate Academy really concern for you, that's why we come with this particular series. So in this series, I am going to discuss the subject power electronics. And yesterday we had a fantastic session on power electronics where we discussed power semiconductor devices and DC to DC converter. Today we will be discussing about the inverters first and then rectifiers, and this is how we will finish this session. So if you have covered these two sessions, you are almost prepared for the power electronics. Okay, so let's get started. Very good evening, Divya. So let's get started with the second session on power electronics under Gate Score Booster series. So we will discuss first inverters. So what are the important topics that we have to discuss here? You will get questions related to single phase VSI and CSI, most probably from VSI. Then there are three phase inverters, 180, 120 degree inverter, which is also very important. Then there are voltage control of inverter, which is very important. This topic is very important. You will surely get a question in the GATE exam from this particular topic. What is the weightage? You can get marks, you can get questions of around 2 to 3 marks from this particular chapter. So 2 to 3 marks, one particular chapter of a subject is a very important thing, isn't it? So let's get started with the very first question. So just see, this is the first question that I have for today from inverter. And what has been said in this question is a single phase full bridge voltage source inverter operating in a square wave mode supplies a highly inductive load. The inverter time period is T, then the duration of conduction of freewheeling diode and percentage of seventh harmonics with respect to first harmonic will be what? So you have to comment upon what will be the duration of a freewheeling diode for which it will conduct. And secondly, you have to calculate the ratio of seventh harmonic to the first harmonic. Okay. So this is a kind of MSQ question that we have, and these are the options you have to choose among them. So let me give you time first of all. Okay, let me see whether you are approachable, whether you are making a right approach for this question or not. So your time starts now. Let me see who among you can answer this question correctly. So let me be aside so that you can have a look over this question. We are talking about single phase full bridge voltage source inverter. Okay, and it is having a very high inductive load. So inductance is dominating at the load side. You can assume pure inductance. So if you have pure inductance and inverter is operating in square mode, output voltage is a square wave, you have to check for what will be the shape of current, and then for what duration the diode is conducting and for what duration the switch is conducting. Yes, Divya, you are right. Absolutely right. Okay. But you can solve this question with the fundamentals of power electronics that we have discussed. Okay. How? I will let you know. Nilmesh is saying option number B. Okay. Good evening, Nilmesh. Option number B. Okay. So let's see how we will approach for this problem. So we have single phase full bridge voltage source inverter. Okay. So each switch will be having an anti-parallel diode with it as well. Now the output voltage is, it has been said that it is operating in square wave mode. Okay. So output voltage is a square wave like this. So this will be the output voltage. Okay. Now what about the current? So current, as you know, we have the pure inductive load. Okay. So this is the output voltage that we have. Let me plot output voltage and current. So this will be the output voltage. It will be having a magnitude of plus Vs to minus Vs. And if we have a pure inductive load, the waveform of output current will be a linear waveform. Okay. So like this, you will be having a waveform of for the current. Just see, current waveform will be a linear one. Across inductor, you know that you have a linear voltage waveform, linear current waveform. So now, this duration we will call it phi, okay, and this duration will be t by 2 and t by 2, okay. This duration will be t by 2 and this will be t by 2. For t by 2 duration, we are turning a switch on and turning a switch off for as well. Now if you see, this is our output voltage and this is the output current. Okay. So if you see, the output current is lagging the output voltage by an angle phi, isn't it? Output current is lagging the output voltage by an angle phi. So how you will calculate this angle phi? Okay, so this angle phi will be tan inverse XL over R, because inductance is dominating. Okay, we have RL type of circuit, we can assume. Now if inductance is dominating, means there is no resistance, we will be having tan inverse infinite or 90 degree, isn't it? So phi angle will be 90 degree. So if phi angle is 90 degree, okay, then what will be the duration for which the diodes will be conducting? Just see, diode will be conducting for this duration. Okay, so this duration we can say this is 180, then this will be 90 degree. Okay, so if it is t by 2, then what will be this duration phi in terms of time? It will be t by 4, isn't it? So the diode or any of the switches, okay, not only diode, any of the switches, they will conduct for a duration of t by 4 only. Okay, they will conduct only for the duration of t by 4. Fine. If we have pure inductive load, any of the switches, they will conduct for t by 4 duration. Either it is diode or the switches. Okay. Now next thing that we have to calculate. So we got one answer. Next thing that we have to calculate is the ratio of 7th harmonic with respect to the 1st harmonic. Have a look on the output voltage. So what type of output voltage we are having? The output voltage is a pure square wave, isn't it? So for a square wave, what is the Fourier series expression? Can you tell me? For a square wave, you know that if you write the Fourier series expression, you will get this expression, n equals to 135 to infinite 4 Vs over n pi sine of n omega t, isn't it? We also have covered this particular topic in the fundamentals as well. So this will be the output voltage Fourier series expression, isn't it? Now what we have to calculate here, we have to calculate what could be the ratio of 7th harmonic with respect to the fundamental harmonic. Okay. So if we are going to put n equals to 7, we will get 7th harmonic. So it will be 4V upon 7 pi. If we are going to put n equals to 1, we will get first harmonic. So it will be, we will get the fundamental term, which is 4V upon pi only. Okay, we will get 4V upon pi only. So what will be the result? It will be 1 by 7. 1 by 7 means 0.1428, or you can say approximately 14.3%. So just see 1, 2 and 3 line and you have got your answer. So what will be the answer? 14.3%. Okay. So if your load is purely inductive load, each switch, whether it is diode or any particular switch, will conduct for t by 4 duration. Okay. If suppose load is other than inductive, means if suppose we have R load, then freewheeling diode will not conduct. Each switch will conduct for T by 2 duration. And if suppose we have an RLC combination, in that case, diode will be conducting for phi duration, and the latter half 180 minus 5 will be the duration for conduction of the switches. Okay, this is how you can calculate the duration of conduction. And for a square wave output, this is the Fourier series expression. So if you have a better practice of writing this Fourier series expression, you can easily calculate all those things. Okay, whenever you have to calculate the ratio of any harmonic with respect to fundamental, it will be equals to 1 by n. This is what you can store in your mind. Let us suppose this is third harmonic with respect to first. Answer would be 1 by 3. Let us suppose that this is fifth harmonic with respect to fundamental. Answer would be 1 by 5. So next time onward, you don't have to write the expression. Just remember this fact. If you have to calculate the ratio of a particular harmonic with respect to the fundamental, it will be simply 1 by n. Okay? N is the particular harmonic about which we are talking. So this is how you can solve these kinds of questions. Okay? And this is very important as well. You may expect this kind of question in the exam. So I hope this is clear to everyone. Any doubt? Nilmesh, Divya, Shailja, Nitya, any doubt that you are having? Everything is clear? Okay. Then go for the next question. Just see this question. In a single phase full bridge inverter, as shown in figure below, is operating at a fundamental frequency of 50 Hz. The RMS value of fundamental component of load current will be. Okay. You have to calculate what will be the RMS component of fundamental output current. Okay. This is what you have to calculate here. Okay. And this is the full bridge circuit given to you. Load is purely inductive, so it will be maintaining constant current. Okay, we can assume like this. Okay, or forget about this. So what we have to calculate here? We have to calculate the fundamental RMS output current. This is what you have to calculate here. So finding this is very easy. What we have to do? Or let me give you time first of all. Let me see whether you are able to solve this question or not. So Nilmesh, for last question, your answer was absolutely correct. Okay. Now I want a correct answer for this question as well. And come on guys, you can solve it. So Divya was, whether you are able to understand the last question? Aryan is saying 31.54. Nilmesh is saying 9903.47. Nilmesh, you are getting extraordinary answer for this time. Aryan, your answer is absolutely correct. Well done. 31.57. 31.5 is the correct answer. Nilmesh, just cross check your answer once. So how to approach for this question? Okay, those who are not able to solve, just see here. So we have to calculate the fundamental RMS current. Okay, so this will be simply what? Fundamental RMS current. If you want to calculate this will be simply fundamental RMS voltage divided by the fundamental impedance. Yes or no? isn't it? Fundamental voltage divided by the fundamental impedance. Okay, so we need to calculate the fundamental RMS voltage and the impedance both as well. So how to find that? Okay, so this is a VSI, isn't it? So for a VSI, for single phase VSI, okay, and even that is of full bridge, what could be the possible output voltage waveform? You know that it will be a square wave. Okay, it will be a square wave type waveform that you will be getting like this. Okay, now this magnitude will be Vs and this will be minus of Vs. So for this kind of waveform, if you will write the Fourier series, what will be the possible Fourier series? So we have written this Fourier series in the first question as well. So it will be 135 to infinite 4 into what is the magnitude? Vs upon n pi sine of n omega t, isn't it? This will be the Fourier series expression. We need the fundamental RMS voltage. So what will be the fundamental RMS voltage from here? If you will calculate the fundamental RMS voltage, okay, then what you have to do for fundamental, you have to pick n equals to 1 here. So it will be 4 Vs over pi, and for RMS you have to divide it by root 2. So you may write it that it will become 2 root 2 Vs over pi. This will be the fundamental RMS voltage. Okay, very good, Nimesh. This will be the fundamental RMS voltage. Okay. Now, after that, what we will be doing? We have to find the impedance as well. Okay. So, normally, how do we write the impedance? Zn angle phi n. Okay. This is equals to, on the sake of impedance, we have only the inductance here. So, it will be what? It will be simply n omega L, and for inductance, the angle will be 90 degree. Now, since we have to find fundamental impedance, so it will be what? It will be omega L, and angle will be what? Angle will be 90 degree. Okay. So this will be the fundamental impedance. This is what you have to calculate. Okay. You have put L instead of, you have written L instead of omega L. Okay. So this will be the fundamental impedance. Now, if I talk about the magnitude only, because we need the magnitude, it will be omega L or XL only. Okay. So now we need to calculate the value of XL. So what will be the value of XL? Okay. Simply 2 pi FL. Okay. So what will be now the value of fundamental RMS component of current? So fundamental RMS component of current, which we have written that it will be equals to fundamental RMS voltage divided by the fundamental impedance. Okay. So fundamental RMS voltage is 2 root 2 Vs over pi, and impedance it is equals to XL or omega L. Okay. When omega L, you may write it 2 pi F into L. So now you only have to put the values. So it will be 2 root 2 into, what will be the value of Vs? 1100 divided by pi, which is 3.14 into 2 into pi again, which is 3.14 into, what is the value of F? F is given 50 and L is 0.1 Henry. So 50 into 0.1 Henry. Now what you have to do, you have to solve this expression, and answer that you are getting is around 31.5 amperes. Okay. I hope you have also solved in this manner. Is that correct, Aryan and Nilmesh? Okay. Yes, you have put L instead of omega L. Very good. So better that you have realized where you don't have to do the mistakes. Okay. So I hope it is clear to everyone. Those who are not able to solve right now, they have understood how to approach for these kind of questions. Okay. Everybody is prepared for the voltage. Okay. Everybody is prepared for any value of the voltage, but they are not prepared for calculating the currents. Okay. And that's why I have included this question. Sometimes you may be asked to calculate a particular current as well, fundamental, third, or any other component of current. Okay. This is how you have to approach here. Now, moving towards the next question. So this is my next question. In a single phase full bridge inverter as shown in the figure, same circuit we have again, is operating at a fundamental frequency of 50 Hz, the peak value of load current will be. what will be the peak value of load current? This is what you have to calculate, okay? So here you don't have to calculate any particular component of current, you have to calculate what will be the peak value of current from the waveform. And your time starts now. Let me see whether you are able to solve this question as well. Take your time, don't be in a hurry, okay? And I want a correct answer from each one of you. Aryan is saying 55, okay? Aryan, are you sure about it? 55? Neelbase is saying 44.54, okay? Are you calculating any particular component of current? And that's why you are getting this answer. We have to find the peak value of load current, okay? Not any component, the peak value of load current. Okay. So what type of load we have here? We have pure inductive load. So how your current will be varying across a pure inductive load? Tell me. The variation of current will be like this, isn't it? It will be varying linearly from certain maximum peak value to minimum peak value, again from minimum to maximum peak value, like this, isn't it? Let me call this value to be minus of IP and let me call this value to be IP. Okay, so this is how I naught, the output current will be varying. And they are asking you this same value of IP. Okay, they are not asking any component of current. Is that clear to everyone? First of all, tell me. So they are asking you to calculate the value of IP. Okay, have you calculated the same value here as well, IP, or you have calculated, I think the answer that you are getting, you have calculated any component of current. Okay, so now when you have turned on switch S1 and S2, what will happen? If you will apply KVL, if this is your VS voltage, okay, and if this is your VL voltage, what will happen? VS will be equals to VL, isn't it? When any of switch is on, okay, so for first T/2 duration, what will happen? Here you will be having S2, S1, S2 conducting, and here you will be having S3, S4 conducting. Okay, let me mark this duration. For switches, okay. So if suppose diodes are there, they will also take part. So I'm not talking about diodes here, okay. Let us take only S1, S2 here. So what will happen when S1, S2 are on for first T/2 duration? What you will be having here? You will be having the inductor voltage exactly equals to the source voltage, isn't it? And if we write for inductor voltage, this will be di upon dt equals to Vs, okay. Or you may write di by dt, this is equals to Vs over L. Now di is the change in current. So how your current is changing? So if you see the change in current for any T/2 duration, it is changing from minus IP to plus IP, or plus IP to minus IP, isn't it? So can we write it from IP to minus IP, or minus IP to plus IP, whatever you want to write. And this is happening during half of the duration, means T/2 time, okay. And this will be equals to then Vs by L, okay. So this will become what? This will become, just see, this we can write 4 IP and by T, this is equals to Vs over L. Or what will be IP? So IP will become 1 by T might be F, so we may write it Vs upon 4 F into L. So this will be the required expression to solve this particular question. Now once you will put the values, Vs is 1100 divided by 4 into, what is the frequency that you have? Frequency is 50 Hertz. Okay, and what is the value of L? 0.1. Okay. So when have you solved in a same manner? And after that, what answer you are getting? I think I am having the wrong answer, because I have taken different data. So once you will solve this expression, you will have 1100 divided by 20. So 55 is the right answer, which Aryan has got. Okay, very good, Aryan. Very good. Okay. I have taken 200 here, and that's why I was getting different answer. The voltage is 1100. Okay. So yes, Aryan, your answer is absolutely correct, and Nilmesh is also getting the same answer. Very good. Very good. You people are in great touch of power electronics. Okay. Very good. So you may expect this kind of question as well. Now see, students are expecting to calculate any fundamental component or any other component of current, RMS value, peak value. You may also get a question like this where you have to calculate the peak value of current only. Okay. So be ready for this question as well. Okay. They can be the part of GATE exam as well. Very good. Now moving towards this question, just see here. So in this question, what do we have? A single bridge inverter delivers power to a series connected RLC load with R, omega L are given. The inverter switching frequency is 10 to the power 4 Hz. The value of capacitance required in the load to obtain load commutation for the SCR in microfarad will be what? And we have been given that the circuit turn off time is 15 microseconds. Okay, so what has been given to us? The value of resistance is 3 ohm. And omega L, which we can write XL, is also given 12 ohm. Okay, and inverter switching frequency is 10 to the power 4 Hertz. This is the switching frequency of inverter. Then what value of capacitance is required? This is what you have to calculate. Okay, and you can also take the circuit turn off time to be 15 microsecond. So all these data are given to you. Now you have to find the value of capacitor. Okay, so I will give you 3 minutes for this question because it can take calculation time. So your time starts now. The way we have calculated answer in the first question, the same approach you have to apply here. Okay, this is the hint. And what type of load we have? The load that we have is an RLC type of load. Okay. Take your time. Okay. And I want a right answer from you guys. So in GATE exam, there are total 65 questions and you have been given 180 minutes. So approximately you have 3 minutes for each question. Now some of the questions may be solved earlier as well. So that time you can dedicate into the lengthy or tough questions. Okay. So you may have 3 minutes for this question. But I want a right answer from you guys. last 1 minute. So last 15 seconds. So guys, if suppose in first question you have seen that we had pure inductive load and the current was lagging the voltage by an angle phi, isn't it? If we have RLC load, current may either lead or lag the output voltage by an angle phi, and RLC load is there. So how to find that particular angle phi? Okay, so that particular angle phi you may find like this: tan inverse, okay, XL minus XC over R. Tan inverse XL minus XC over R. This is the formula that you have to use. And since what has been said here is the value of capacitance required in the load to obtain the load commutation possible, that means capacitance might be having high value. So you may write XC minus XL as well. It does not matter. Okay, sign difference will only be there, and that you don't have to write. You have to calculate the value of capacitance. Okay, so anything is fine if it is not clear to you. Now this instant phi, okay, this you will be getting on the waveform. If suppose your waveform is like this, if your waveform is like this, then this is the angle phi. Okay, so what is this axis? Is omega t axis. Okay, so what we can write for this is that phi is basically omega t, and t I am writing Tc. That is equals to tan inverse XC minus XL over R. Okay, so in this expression, if you see, omega is known to us, Tc is known to us, Xc is what we have to calculate, XL is also known to us, and R is known to us. So first of all we have to find Xc from this expression. Okay, and there are also some calculation mistake that you guys can commit here. Okay, so what expression we have, just see. You have to be very careful while solving this. Omega Tc, this is equals to tan inverse X of C minus X of L by R. This is what we are having. What we can write for omega is 2 pi f. Okay, 2 pi f into Tc. This is equals to tan inverse X of C minus X of L upon R. Now put the values. So 2 into 3.14 into frequency is 50 and the time and circuit turn off time is given. Frequency is 10 to the power 4. Okay, not 15. Frequency is 10 to the power 4 and the circuit turn off time is given 15 microseconds. So you may write it 15 microseconds. Now here it will be tan inverse X of C minus, what is X of L? 12. And what is the value of resistance that we are having? It is 3. Okay. Now when you will solve this, okay, when you will solve this particular thing, you will get 0.942 radians. Okay, this is equals to tan inverse Xc minus 12 upon 3. The value that you will get from here is in radians. Now when you will convert this into angle, it will become 44 degree. Okay, so don't forget to do these steps, unless if you will directly take tan of this will be wrong. Okay, so now what we will get, Xc minus 12 by 3, this will be tan 54 degrees. Okay, and what is tan of 54? It will be around 1.37. Okay, so now we only have one unknown here, and which is X of C. So what will be X of C? 1.37 into 3 plus 12. Okay. So from here you will get Xc equals to 16.11. And what is Xc? 1 upon 2 pi Fc. This is equals to 16.11. So what will be the possible value of C? It will be 1 upon 2 pi. What is F? 10 to the power 4 into Xc, which is 16.11. Okay. Now when you will solve this, the answer that I am having is 0.98 microfarad. 0.98 microfarad, or you can approximate and write 1 microfarad. That is also acceptable. Okay. So this is how you have to approach for this kind of question. Okay. Now these kind of questions have never been a part of GATE exam from inverter, but be ready. That is the purpose of this series, to give you a flavor of all kind of question, expected questions, to make you aware of all the formulas and all the important topics from where you can expect a GATE question. So I hope that the series is really serving its purpose. Okay, so you may expect this kind of question as well, and these type of questions are also very important for GATE point of view. Okay, be ready for these questions. So this is how you have to approach for this question. Okay, is that clear? Nilmesh, Aryan, Divya, Selja, Nitya, everybody, is that clear right now? Whether this question is clear, any doubt anybody is having? Very good. Okay, now moving towards the next question. Just see this question. This is from CSI. So in the current source inverter CSI shown below, the load is purely resistive. The maximum output frequency obtainable in kilohertz will be. Okay, what could be the maximum possible frequency you will get in this particular circuit? Okay, so many of you are aware of this formula, that f of max, it will be equals to 1 upon 4 RC. Okay, 1 upon 4 RC. This formula, many of you are aware of this formula. Okay, but how we are approaching towards this formula, you should also know about that, because sometimes if the C value is same, you can directly apply this formula, but if the C value is not same, different, then you should think about it. Okay, so just see how you will be making this formula approachable. So in CSI, okay, in CSI, how your output voltage will be varying? So the variation in output voltage will be like this. It will be varying from some minus V to plus V. Okay, like this. This is how the output voltage will be varying in a CSI inverter. Okay, this is T by 2 time and this is T time. It will be varying from certain minus Vs to plus Vs value. Okay. Now just see, when you must be having capacitor here, isn't it? So when is the steady state is being reached? Minus Vs to plus Vs you are reaching in T by 2 time, isn't it? So a steady state is being reached in T by 2 time. Okay, you are reaching from minus Vs to plus Vs. You are making a transition and then you are getting to a steady state at T by 2 time. Okay, so steady state is being reached in time T by 2. And you know that in RC circuit, what will be the possible time constant, or what is the time taken to reach the steady state? It will be equals to 4 tau, isn't it? The time taken to reach to the steady state will be 4 tau, where tau is the time constant. And in the circuit you are reaching, as per the waveform, you are reaching this steady state from minus V to plus V in T by 2 time. Okay, so if we equate this, what we will be getting here? So T will be equals to what? 8 times tau, isn't it? Now what is tau? Tau is the time constant. So what we will be writing here? R into C equivalent, because we are having two kinds of C here. Now just see, for any of the C, what path we will be following here? If we are following this particular path, okay, and coming like this, okay, if we are following this path and coming like this in the circuit, the both the capacitance that we are getting here in this lineup appear to be in series or in parallel? Obviously they appear to be in series, isn't it? So if you have to find C equivalent, how you will be writing C equivalent? This will be R. Both the C are in series with each other. So you will write series combination. So C into C upon C plus C. Capacitor in series will be treated like the resistance in parallel. Okay. So what you will get from here? You will get C by 2. So C by 2 means you will get 4 RC. This is the time period. So what will be the frequency? It will be 1 upon 4 RC. Okay. So this is how you will get this expression. Now if suppose these C's are having different values, here the C's are having the same value, so you can directly write this formula. But if the C are not same, you have to modify this formula. Here you will be writing C1 C2 upon C1 plus C2, and you will not be getting 4 RC or 1 by 4 RC as frequency. You will get something different. So that's why I did this analysis. Okay. So in CSI, do not forget to take this thing. Now gate authority, they may give you a question like this in which C might be having different value. Then what you will do? If you are able to apply this question, this formula directly, you won't be able to. You will be in a dilemma which capacitor has to be chosen. Okay. So then this analysis will be helpful to you. Now I think there is no problem because you know all the values. 1 upon 4. What is the value of resistance? It is 8. And capacitance 0.2 microfarad. So after putting the values, when you will solve it, you will get 156.2 kilohertz. Okay, 156.2 kilohertz as answer. So is that clear to you? Nilmesh, Aryan, Divya, Selja, Nitya, everybody, just give me an answer. Is that clear? How to approach for these kind of question, is that clear? Okay, so do not forget to do this analysis unless you can do a mistake in these questions. Okay, 1 by 4 RC is applicable when both the capacitance are same, and normally we used to keep both the capacitance same. If suppose they are not same, then this analysis will be useful for you. Okay, very good. So we are done with this question. Now moving towards the next question. Just see this question. A three-phase bridge inverter delivers power to resistive load from 400 volt DC source for a star connected load of 10 ohm per phase. So we have a star connected load of 10 ohm per phase. And when we are analyzing 180 degree or 120 degree inverter, we also have taken star load to get the value. So whatever values we are getting for output voltage is for star load. If suppose the load is delta, you have to convert that particular load into star load. Okay, and then those formulas are equally applicable. The ratio of power delivered to the inverter when it is operated in 180 degree and 120 degree mode respectively. So what you have to calculate? You have to find what will be the ratios of power in 180 degree to 120 degree. This is what you have to calculate here. Okay, and your time starts now. And I call this to be a very interesting question. Okay, an ideal question for gate. Okay, because it has all the recipe to become a gate question. The ratio of power delivered in 180 to 120 mode. Okay, very good, Aryan, you are very rapid. 1.33. With the lightning speed you have solved this question. What is the answer that everybody else is getting? Aryan, are you from IMS Gate Academy? So last 1 minute. Let me verify the answer that Aryan is getting. 1.33. all you need to know to solve this question is what is the phase voltage of 180 degree and 120 degree inverter. Okay, and rest, it is a very easy question, isn't it? Okay, so those who are not able to solve, just see here. So we have two kinds of three-phase inverter, 180 degree and 120 degree, and you should know the values of phase voltage and the line voltage here. So what is the phase voltage and line voltage in 180, and what is the phase voltage and line voltage in 120? Okay, so phase voltage in case of 180 degree inverter, it is root 2 by 3 times the source voltage, and line voltage, it is under root 2 by 3 times Vs. Phase voltage in 180 degree and 120 degree inverter, it is Vs upon root 6, and here it will be Vs upon root 2. So these values you should know. Okay, you have to practice to know about these values. Then power delivered. What will be the power delivered? Power delivered will be 3 V phase square divided by the resistance. Okay, because we have been given the resistance per phase. Now, if suppose I have to calculate the ratio of power delivered in 180 degree to the ratio of power delivered in 120 degree, then what will be the answer? We will get 3 V phase in 180 degree is how much? Root 2 by 3 into Vs, which is 400 volt. Okay, or I can simply write Vs here, because Vs will get out, it will be cancelled. Root 2 by 3 Vs square. Okay, and it will be divided by R. This will be for 180 degree. Simply we will get for 120 degree, which is Vs over root 6 square divided by R. Okay, so Vs square and R will get cancelled. 3 and 3 get cancelled, and finally when you will solve it, you will get an answer of 1.33, which Aryan is getting. Very good, Aryan. Okay, Nilmesh, are you getting the same answer? And what about Divya, Selja, Nitya, Niharika? Whether you are getting 1.33 as answer? Tell me guys, this question is a perfect recipe for particular for GATE exam. Okay, you can expect this kind of question to be a part of GATE exam. Here I have asked the ratio. They may be asking you individual powers. Okay, so you have done for 180, 120 both in this question. They may be asking only for particular converter. Okay, so if you are known to this particular formulas, nobody can stop you getting 2 marks related to this question. Okay, so very good. Now moving towards the next question. So just see this question, and here you have to use your brain. Whatever we are talking about, we have to utilize here. A 3-phase voltage source inverter as shown in the figure is feeding a delta connected load. Whatever formula we have written, while getting those formula, while doing the analysis, we have assumed star load, isn't it? And here we have been given the delta load. So what we have to do in that case? Okay, I'm leaving that to you. It is fed from 600 volt battery with 180 degree conduction of solid state devices. The reactive power consumed by the load in kVAR will be, you have to find the reactive power consumed. Okay, and your time starts now. Only difference is we have 180 degree conduction mode only, and in that the load is given in delta. Okay, so I told you what you have to do if the load is in delta. Because the formulas that we are having, we have derived for by considering star connected load. If you have delta connected load, you know what you have to do. Delta might be converted into star. Okay, this is the hint. Now you can solve this question easily. Load is 50 ohm plus J50 ohm per phase, and it is delta connected. So let me see who can solve this question. So last 1 minute, okay. Whatever formulas we have derived assuming a star connected load. If the load is delta connected, okay, then what we have to do? If you don't want to indulge yourself in star delta concept, you have done everything for star. If you have delta connected load, better you convert that into star, okay, and this is how you can simplify your problem. Then you don't have to struggle whether phase or line or phase, what we have to use, okay. So just see, a star connected load per phase will be what? Load impedance per phase. It will be delta connected impedance per phase divided by 3. How I am getting this? If we have same impedance connected in delta, their star equivalent per phase will be Z by 3, R by 3, okay. So when you will do this, what you will get? 16.67 plus J 16.67 ohm per phase, okay. This is what you will get. Now what we have to do? We have to find the reactive power, isn't it? So reactive power will be simply 3 V phase square divided by X. In order to get the reactive power, we only have to use the reactance, not the complete impedance, isn't it? So what you will be doing here? V phase, what converter we have? We have 180 degree converter. So in 180 degree converter, what is the phase voltage? The formula for phase voltage is root 2 Vs by 3, okay. So you will square it, and the X value here will be 16.67. So ultimately what we will be getting, just see, it will be 3 into 2 Vs square. How much the value Vs is having? 600 square divided by 9, and finally it is divided by 16.67, okay. So what answer we will be getting? We will be getting 14.40 kVAr, okay. Answer will be 14.40 kVAr, which is given in option number C, which will be the right option. This is how you have to proceed for this kind of question, okay. And I am sure you must be getting a question related to the power calculation of either the 180 degree converter or the 120 degree converter, okay. So the two problems that we have discussed right now, in which the first case we have calculated the ratio among the two power converters. Then we have specifically discussed this problem for 180 degree converter. If the load is not star connected, it has delta connected. So this is how they can modify the problem, okay. So all the scenarios we have discussed here, and right now you are very well prepared for these kind of question, isn't it, Nilmesh and Aryan? Okay, so be ready to get this kind of questions. Moving towards the next question, just see this one. A chopper is providing input to 3-phase 180 degree voltage source inverter, okay. So what do we have? You know that inverter is fed by a DC battery, isn't it? DC voltage source. So that DC you are getting from a boost converter, isn't it? This is a kind of boost converter because inductor is present at the input side. So it is a kind of boost converter we have, okay. So this boost converter is feeding to this inverter, which is 180 degree VSI. Load is star connected and the value is 20 ohm per phase. Very good. Chopper is operating at a duty ratio of 0.8. Let me write this. The duty ratio for chopper is 0.8. Then the total power dissipated across the load will be what? Again, we have to find what will be the power dissipated across the load. Okay. Load is star connected, not at all a problem. So what we have to do? If you want to calculate the power dissipated, formula is very simple. 3 V phase square divided by R. Okay. What is the value of V phase in 180 degree inverter? It is root 2 Vs by 3. Okay, divided by what is the value of R? It is 20. So finally what you will get? You will get 2 Vs square by 60 here. Okay, or Vs square by 30 simply. But do we know the value of Vs? Do we know the value of Vs here? Okay, so Vs value I think we are not having here. Isn't it? Vs value is not with us. Whatever will be the output of this boost converter, okay, that will be the input voltage for our VSI. Okay, so for a boost converter, what do you know? For a boost converter, the output voltage is input voltage divided by 1 minus D. So input voltage for boost converter is 220 divided by 1 minus D is 0.8. So how much we will get? 220 upon 0.2. Okay, so I think it will be 1100. So 1100 volt will be the output voltage of boost converter, or it will be the input voltage. It will be the input voltage to our 180 degree VSI inverter. Okay, so now you can put the values here. 1100 is square divided by 30. When you will calculate it, you will get 30.25 kilowatt as answer. You will get 30.25 kilowatt as answer, which is given in option number A. Okay, Aryan, you are getting 40.33, but my answer is 30.25. Okay, just cross verify. Just cross verify it. We have 180 degree inverter, or let me verify. Maybe my answer will be wrong. Let me do it. Yes, it is 40.33. Nilmes is also getting the same answer. Very good, Nilmes. It is 40.33. So mine answer is wrong. Okay. It will be 40.33, which means option number B will be the correct option. Okay. Option number B is the correct option. So this is how we can solve this particular question. Okay. What has been given here? This is a combination of chopper plus inverter. Okay. Now they may modify this. They may just reverse the chopper. They may just give you another chopper. Maybe buck boost converter might be here. Okay. Maybe you may have delta connected load here. Maybe you are having 120 degree inverter. So this is how they can modify, but this is a very interesting and very good question. Okay. If I am the exam setter, I will definitely go for this question in order to check whether students are aware of multi-concept questions. They are aware of multi-conceptual part of the questions as well or not. Okay, so I will definitely go for these kind of questions. So this makes this question a very important one. Okay, I hope you liked it. Now moving towards the next question. Okay, so just see this question. A single phase full bridge inverter has maximum fundamental output voltage of 300 volt. Okay, single phase full bridge inverter has maximum fundamental output voltage. What has been given? Single phase full bridge inverter, and it is having maximum fundamental output voltage equals to 300 volt. The output voltage is now controlled by using single pulse width modulation. Earlier they were using directly. And a pulse width of 72 degree per half cycle is being chosen. Okay, so with PWM, what do we have? With PWM, we are choosing the pulse width of 72 degree. If the total RMS is reduced by 1/4 of its value, then the power delivered to the load resistance of 10 ohm will be what? Okay, so I leave it up to you. let me give you some time and let me see whether you can solve this question as well. So firstly we have been given the maximum fundamental component when we are not using PWM technique. Then when we are using PWM technique and choosing this pulse width, total RMS voltage is reduced by 1/4. Okay. Then what will be the power delivered to a load resistance of 10 ohm? This is what you have to calculate. First, we are not using any PWM, then we are using PWM. Okay, there are two scenarios. Take your time and I want the correct answer, okay? You can expect this kind of confusing questions in the exam. You know everything related to this, but a lot of confusions are there, okay? With PWM, without PWM. So let me check your analytical power in this question. Okay. So see, what do we have here? So first, what has been given to us? First we have V0 fundamental, which is 300 volt and without PWM. Okay. So fundamental output voltage. What is the Fourier series expression without PWM? Okay. This is the expression. N equals to 135 to infinite 4 Vs over N pi, the DC voltage, sine of N omega t. Now from here, if I calculate the fundamental voltage, so fundamental voltage, it will be 4 Vs over pi. Okay, and this has been given to us, which is 300 volt. So you will get the value of Vs from here, which will be 300 pi over 4. Okay, so when you will solve it, what value of Vs you are getting? You will get 235.5 volt. Okay, 235.5 volt. This will be the value of Vs. Okay, so from the given data we have calculated Vs. Now just see, if we are using PWM, so with PWM, if we talk about with PWM, and then what is the pulse width? Pulse width is given 72 degree. So what will be the value of D? 36 degree. Okay, and at that time we are talking about total RMS voltage. So what will be the total RMS voltage? Formula for total RMS voltage is Vs under root 2D over pi. Okay, so Vs we have calculated 235.5. Let me use more space. So Vs is 235.5 under root, what is 2D? 2D is given 72. What is pi? 180 degree. Okay, so when you will solve it, you will get an output voltage of, what I am having is 148.94. Okay, 148.94 volt, not degree, it will be in volts. Okay, so that is the output voltage, total output voltage. This is what you will be having for this particular pulse width. But now they are saying if RMS is reduced by 1/4, then what is the power dissipated? So this is the RMS that we have. Okay, so when we have reduced this RMS by 1/4, okay, so new RMS voltage will be, or we can write it V0 RMS dash. This will be the old RMS voltage when divided by 4. So we have 148.94 divided by 4. Is that correct? Yes. So when you will divide it by 4, how much you will be getting? 37.23. Okay, 37.23 volt. So this is the voltage that we have to use. Now what will be the power dissipated? We have single phase inverter. So power dissipated will be simply V0 RMS. Okay, the new RMS voltage is square divided by the resistance. So you will write 37.23 square divided by the resistance value is 10. When you will do this, you will be getting 138.65 watts. Okay, 138.65 watt. And Aryan, you are very close to that answer. So your answer is correct. Okay, very good, Aryan. And Nilmesh, you are getting 281. I think you are using the old voltage. Is that correct? Cross check your answer. What mistake you have done? 138.65 or 138 point something is the correct answer that Aryan is having. Okay, Nilmesh, just have a cross check to your answer. Okay, so 138.65 will be the correct answer. So you know everything related to this question, but they have given a lot of data. They have asked, they are asking for a lot of things. So there are chances that you may fumble in this question. Okay, so you have to understand the language of the question very clearly, and rest everything you are having with you. Okay, so there are high chances that you can commit a mistake in this question, that you have to avoid. Okay, I hope you got what is the problem. Now just see this question, a very good question. So what has been said in this question is, we have a single phase voltage source inverter VSI which is feeding an RL load as shown in the figure. Okay, so we have a single phase VSI which is feeding an RL load. This is the value of VS that we have. Okay, this will be the value of VS for us, source voltage. So this is our VS. Now it is controlled by sinusoidal PWM technique. The reference sinusoidal wave and carrier triangular wave of 10 kilohertz frequency are shown below. So we have the reference voltage and the carrier voltage. Okay, so what is the magnitude of the reference voltage? And let me read out the full question. The reference wave is given as VR equals to 1 sin 100 pi t. So reference wave is a sinusoidal wave whose amplitude is 1. R is 8 ohm, XL is 12 ohm at 50 hertz. Then RMS value of fundamental component of current will be what? You have to calculate what will be the RMS value of fundamental component of current. This is what we have to calculate here. Okay, this is what we have to calculate. And what has been given to us is the value of reference voltage is how much? 1 volt. The peak value of carrier voltage. Okay, this is the peak voltage. Peak value of carrier voltage is 2 volt. So we can calculate the modulation index here, which is the peak of VR to peak of VC. So 1 by 2, and you will get 0.5 volt. Oh, sorry, 0.5. And rest I leave it over to you. So I am giving you 4 minutes for this question, and I want a right answer from you guys. If you are able to solve this, you are almost prepared for all kinds of questions. Okay, you can't get a question tougher than this one. Even you will find this question as easy as well. Okay, so you have 4 minutes, and I want a right answer from you guys. What we have to calculate? Fundamental RMS component. So your time has already started. Just solve it. Okay. Aryan is getting an answer 17.33. Nilmesh is getting 12.25. Well, Nilmesh, your answer is correct. Okay, your answer is absolutely correct. What we have to find here is fundamental RMS current. Okay, how to approach for this question? So if we have to find fundamental RMS current, okay. So fundamental RMS current, if you want to calculate, this will be fundamental RMS voltage divided by the fundamental impedance, isn't it? So we need these two quantities. Now how to find this fundamental output voltage? Okay, so just see this fundamental output voltage, this will be equals to M into A into Vs, modulation index time Vs, okay, for single phase full bridge inverter. If it is a half bridge inverter, we will be writing Vs by 2 here. If it is a 3-phase converter, so we will be calculating peak to peak line voltage and we will be writing root 3 MA Vs by 2 here. Okay, but we have single phase full bridge inverter, so this is the formula that we have to use. Then what will be the RMS value? RMS value will be M into A Vs divided by root 2. What is MA? 0.5 we have already calculated. Okay, and what is the value of Vs? 500. When divided by root 2, it will give how much? So the value that I am having is 176.80. Okay, so 176.80 volt, this will be the RMS voltage. Now what we need else is, we need to find the value of Z1. Okay, so this will be what? This will be under root R square plus XL square. Now do we have all the data? R and L values are given to us? Yes. R value and XL values are given. They are 8 and 12 respectively. So we can simply write here 8 square plus 12 square. And what will be the value of Z? This is what I am getting is 14.42 ohms. Okay. So after that, when you will calculate the fundamental RMS component of current, which will be equals to fundamental RMS voltage divided by the impedance. Okay, so it will be 176.80 divided by 14.42. Okay, when you will divide it, you will get 12.126 ampere as the current. So this will be the answer. Okay, Aryan, you are getting 17.33. Is there any calculation mistake that you have done? Nilmesh, your answer is absolutely correct. 12.25 is the right answer. Okay, so this is how we have to go for these kind of questions. And from last 5-year papers analysis, if we go for that, we have seen constantly, okay, every second year, we are getting questions related to modulation index. Okay, so be prepared, guys. All the questions related to modulation index, they are very important for you, and this is one of them. Okay, so just see, we have discussed a question related to modulation index as well. So last 3 questions that we have discussed are very good questions. Okay, you may get to see the same kind of question in the upcoming GATE exam as well. I hope this is clear to everyone. Okay, so this is the end of the inverters, and now I am moving towards the rectifiers. Before that, whatever we are discussing here, you will get the PDF of this session in this particular Telegram group of IMS GATE Academy. You can join this group through this link. Aryan, this is for you. You can join this group through this link. Okay, the link is also available in the description box. If you will join this group, you will get the PDF of this particular session. You will also get some important questions every day, some important quiz and answer, and the information related to career webinar, seminar, information related to GATE, PSU, everything will be available in this group. So do join this. This is very important for you. Apart from that, if you are really liking the teaching and learning methodology of this lecture of IMS GATE Academy, you can also join IMS GATE Academy online program, in which we are offering 800 plus hours of live classes We are also giving you quality material as well, in which we have exercise book. Those contains 4,000 plus questions. 12 personalized sessions will be there, so you can discuss with us the preparation strategy and everything. And we are giving 130 plus online tests, which has 3,000 questions. So together we are offering you 7,000 questions of set. If you prepare those questions, you can crack any exam of the world. So this much flavor you will be getting at IMS Gate Academy. If you are interested, you can call on these numbers, okay, and join IMS Gate Academy. So moving towards the rectifiers. So just see the rectifiers. What are the important topics? So you may get a question from single phase rectifier, you may get questions from three phase rectifier, and nowadays this topic is very important. Effect of source inductance. Okay, questions are constantly coming from this topic as well. Effect of source inductance. What is the expected weightage? 2 to 3 marks. So overall weightage of power electronics. If you are very good in power electronics and if it is your day, you can expect question up to 13 marks from power electronics only. And suppose you are very good in power electronics, 13 marks of questions you are getting from power electronics, you have rocked the exam, isn't it? So let's move towards the questions. So this is the first question that I am having from the rectifier. Just see what has been given here. The source voltage and current in a single phase AC to DC converters are 200 root 2 sin omega t. Only fundamental frequency component is present in voltage, and current is having 10 root 2 sin omega t minus 45 5 root 2 sin 3 omega t plus 45 2 root 2 sin 5 omega t minus 60 degrees. Fundamental, third and fifth harmonic components are present. Power drawn in kilowatt by the converter and current distortion factor will be what? So you have to find the power drawn by the converter and you have to find the current distortion factor. These two things you have to calculate in this numerical. Okay, and your time starts now. Let me see. Are you aware of these concepts as well? Before getting into the rectifier, you should know about this. Okay, so your time starts now. Let me see. Are you able to solve this question? Voltage is sinusoidal, but the current is periodic, but it is not sinusoidal. It is having multiple frequency term. In that case, how to find the power and how to calculate the fundamental, how to calculate the current distortion factor. Okay. Nilbase is saying A and D. A and D. Let's see. So what others have to say about this? A and D. Nilmes, just cross check your answer once again. A and D are correct? 0.88, yes. And I think power value also you are getting different, which is not included in this option, okay? So power I think that you will be getting is, this is wrong, you will be getting 1.4 kilowatt. Okay, so are you getting 1.4 kilowatt? Okay, let me solve this question, okay? So how to approach for these questions when voltage is sinusoidal but the current is not sinusoidal? In that case, you can calculate power by using this formula. The power is V naught I naught, the DC components, okay, plus half of summation I equals to 1 to N I1 V1 cos of theta 1 minus phi 1, where theta n, I have to write n here, okay, where theta n is the angle of voltages and phi n is the angle of currents, okay. So if you expand this, what you will get? You will get V naught I naught plus half of V1 I1 cos of theta 1 minus phi 1 plus half of V2 I2 cos of theta 2 minus phi 2 and so on. Okay. Now if we put the values here, just see, do we have any DC component voltage and current? No. So the corresponding share will be 0 plus half. V1 is the fundamental maximum voltage which is 200 root 2 here. Okay. Similarly I1 is 10 root 2 fundamental frequency component of current. Okay. Into cos of the angle between them. So it is having an angle of 0. It is having an angle of minus 45. So it will be 0 minus 45. Okay. Now plus 1 by 2. Do we have any other component of voltage? No. So all other terms will correspond to 0. Isn't it? So we are only having this term. So what we will be getting here? We will be getting 2000 cos of 45. From here you will get 1.4 kilowatt of power. Okay. So 1.4 is the right answer, which is not there in the option. So I have corrected that. Now after that what we have to calculate? This is how you can calculate power. Or simply from next time onward you can use this trick as well. Whenever you have in such a scenario, you can calculate V0 fundamental RMS. Okay. Then I0 fundamental RMS. Then cos of theta 1 minus phi 1. You can directly write this. So what is V1 RMS here? It will be 200. What is I1 RMS? It will be 10. Cos theta minus phi will be 45. So you will get again 1.4 kilowatt. So next time onward you may use this trick directly. Only fundamental components will be corresponding to the power. Phase displacement you will take only between fundamental component. But how we are approaching for this? This is how we are getting that. Okay. Next thing that we have to calculate is the current distortion factor. So what is current distortion factor? Current distortion factor is the ratio of fundamental RMS component divided by the ratio of total RMS component. Okay. So fundamental RMS component, what is the ratio of, what is the component of fundamental component? 10 root 2. So its RMS value will be 10 root 2 divided by root 2. And how to calculate the total RMS component? This will be I1 RMS square, because we have fundamental term, third harmonic term I3 RMS square, and fifth harmonic term, so I5 RMS square. You will do this and you will get your things. So what will be the answer right now? So we will get 10 from above. Okay. Then fundamental RMS will be 10 root 2 upon root 2 square. Then what are the other components? 5 root 2 and 2 root 2. So 5 root 2 upon root 2 square. Then 2 root 2 upon root 2 square. Okay. So you have to put the values in this, and when you will solve it, finally you will be getting 0.88. Okay. Finally you will be getting 0.88. So this is how you will calculate the current distortion factor. Okay. Now it has not been asked here, but you may calculate that as well. If suppose we have to calculate the power factor, this will be equals to current distortion factor into the displacement factor. Okay. So current distortion factor is 0.88, and distortion factor, it is the cos of angle between the fundamental voltage and fundamental current. So what is that angle? That angle is 45 in our case. Okay. So 0.88 into cos 45 will be 1 by root 2, 0.707. Okay. So when you will multiply them, I think what you will be getting is around 0.44. Need me just cross check whether it is 0.44. Okay, so it has not been asked here in this question, but be prepared for this. This kind of question may be the part of GATE exam as well. This may be, they may ask for this as well. Since it is an MSQ, they may ask for this third thing as well. So Nilbhai, are we getting 0.44 here? The multiplication of 0.88 and 0.707. 0.44 or 0.78, what you are getting? 0.62. Okay, so we will be getting 0.62 here. So be prepared. This may be asked as well. Yes, very good. Okay. So this is how we have to proceed for this particular thing. Power calculation in rectifiers. Now moving towards the next question. A separately excited DC motor when fed from a 230 volt 50 Hz single full phase fully controlled bridge converter with a firing angle of alpha. The motor is initially running at 990 rpm from a 200 volt DC. So when your DC voltage is around 200 volt, your speed is around 990 rpm. Okay. When fed from converter, the motor runs at 490 rpm. So the next speed is 490 rpm when it is fed from a converter. Now it is getting a DC voltage from converter. So we don't know what voltage is being applied here, and you have to calculate what will be the firing angle corresponding to this voltage. Okay, this is what you have to do in this problem. So I hope you can solve this question. So I am only giving you 1 minute for this because this seems to be an easy one. Okay, related to drives. Very good, Nilmesh. You have already calculated. Answer is B. Yes, B is the right answer. Okay. Anybody else who is attempting the question and getting a different answer? Everybody is getting the same answer, B. Okay, then we can stop this clock and we can proceed for it. So first of all, guys, you will be calculating V2. So V2 upon V1 is N2 upon N1. Okay, so from here, what will be V2? It will be N2 upon N1 into V1. So N2 is 490, N1 is 990, V1 is 200. Okay, so from here you will get the value of V2. How much you are getting? 98.98. Okay. Now, this is the DC voltage which when we are feeding to the motor from a converter. Okay. And what converter? Single phase fully controlled bridge converter. So what is the output voltage of single phase fully bridge controlled converter? It is 2 Vm by pi cos alpha, and which you have calculated is 98.98. Okay. So now put the values. 2 Vm will be root 2 into supply voltage is 230 divided by 3.14 cos of alpha, and it is 98.98. Okay, then if you will solve it, your alpha value will be 61.45 degree. Okay, so in power electronic there also has there a topic has been mentioned which is electric drive. So yesterday as well we have solved one question related to chopper from electric drive. This is the next question that I am having from electric drive. Okay, so be prepared for these kind of questions as well, which Nilmesh has given a correct answer. Okay, so I hope you got it, how to solve these questions. Moving towards the next question. A single phase full wave controlled converter is fed from a source of 100 pi sine 100 pi t, is feeding an RE load with R equals to 20 ohm and E equals to 600 volt. If it is operated at a firing angle of 135 degree, then the power in the circuit with respect to the load will be this value absorbed, this value delivered, or this value absorbed or this value delivered. Okay, so what has been given here is input voltage is 100 sine 100 pi sine 100 pi t. Okay, then R value is 20 ohm, E value is 600 volt. Okay, and firing angle is 135 degree. Then you have to calculate power and whether this power is delivered or it is absorbed. Okay, so again I think 1 minute is sufficient for this question, or you can take 2 minutes because it may take calculation time. calculations are there, so don't do any calculation mistake and you can solve this question. Okay. This time single phase full wave rectifier, full bridge controlled rectifier is feeding an RE load. Okay, resistance, and there is E as well. Battery EMF is as well, and the firing angle is 135, which is greater than 90 degree. This is what you have to look forward. Okay. And what will be the direction of power? Whether the load is absorbing the power or it is delivering the power. This is also something on which you have to comment. Come on guys, you can solve this question as well. Okay. This is very easy. And it is a perfect recipe for GATE exam because it has a small confusion here as well. Okay. So last 10 seconds. Still I am waiting for your answers. Nilmesh is saying B. Okay. So see, what we have to do here. Whenever your alpha is less than 90, okay, what will be the load side KVL? Whenever you have alpha less than 90, your load side KVL should be V0 equals to E plus I0 R, okay, and source is delivering power to load. Whenever you have alpha greater than 90, your load side KVL will be V0 equals to minus E plus I0 R. We have to reverse the E because V0 will be negative. And power will be delivered from load to source. Okay. This is what we will be getting. So, and we are under this condition. So, first of all, what will be the V0 value? V0 value, you know, the formula is 2Vm by pi cos alpha. Okay. Okay. And we will be applying E plus I0 R here as well. V equals to minus E plus I0 R here as well. So when you will do that, you will calculate the value of current. We have all the values given here. Just see, 2 into Vm. Vm will be 100 pi. Okay. Vm will be 100 pi divided by pi. Cos of alpha is 135 minus of E. E is 600 plus I0 into what is R? R is 20. So when you will solve it, you will get I0. And what will be I0? E is greater than Vm. Okay, that is also true. So I0 will be 22.93. Okay, I0 will be 22.93. So you will get I0 value. Okay, now what will be the power? Rn is saying E is greater than Vm. So it will feed power towards the source side. Yet Rn, that is also correct. Okay. So you got the value of V0. Now what will be the power? Power will be V0 into I0. Again, V0 will be 2Vm by pi cos alpha, okay, into I0. So 2 into Vm will be root 2 into 100 pi upon pi, and cos of 135 into I0. When you will solve this, you will get V0 value to be negative minus 41.4, and I0 you already calculated as 22.93. Okay, so what you will get? You will get power as minus 3.24 kilowatt. So power is negative. Negative power means power is flowing from load towards the source. Okay. So load will be delivering the power, or it will be absorbing the power. Load will be delivering the power. Okay, which is option number B, which Nilmesh has told is correct, and answer fundamentally you are also absolutely correct. Okay, so just see whether you can calculate and then you can decide, or you can decide from here as well. Okay, for depending upon the value of alpha as well. So this is how you could have approached for this kind of question as well. Now many students, they used to do this mistake in these kind of question. For the particular value of alpha, what KVL we have to write, they don't know. Okay, and this is the mistake that they are doing. But what I can see that you guys are very perfect in that. Okay, fantastic. Now moving towards the next question. Okay, now we will speed up a little bit because we have a lot of questions still to answer. A three-phase full converter supplies a battery from a three-phase supply of 230 volt 50 Hz. The battery EMF is 208 volt. Okay, how much is the battery EMF? 208 volt. And its internal resistance is 0.5. The value of R is 0.5 ohms. On account of inductance connected with the battery, the charging current is kept constant. Okay, I naught is constant, ripple free. And how much is it? It is 18 amperes. If the power is flowing from DC source to AC load, okay, power is flowing from DC source to AC load, so power is flowing from load towards the source. The firing angle delay will be what? Okay, so the concept that we have discussed in the last question are very much useful for you in this question as well. So let me give you some time. So I am waiting for your answers. Okay, we have been given that the power is flowing from load side towards the source side. Then what will be the value of alpha? Okay, and of course the value of alpha should come greater than 90. So these can't be the correct answer. Okay, so only C and D are the options in which you have to choose any one of them. Fine, guys. Conceptually, this is what we discussed in the last question. We have to apply the same thing here as well. So try and get an answer for this question. Sir, how can we calculate theta? And which theta are you talking about? Theta or alpha? I think in this question there is not any involvement of theta. Achha, that theta you are talking about. Theta sine inverse E over Vm. Okay. In previous question, also you can calculate it like this, sine inverse E upon Vm, isn't it? If we have, you know that this concept, if we have E at the load, then when Vm sine omega t, okay, this is at least greater or equal to E, only then you can fire your, then you can turn on your switch, isn't it? Only then the switch can be forward biased, isn't it, Aryan? When your Vm sin omega t is at least equal to or greater than E, only then you can fire your switch, because they are forward biased after that. So what is that particular moment where your firing angle should be, where your voltages are getting equal? Okay, so if you are calling this omega to be theta, theta will be sine inverse E over Vm. Okay, so your firing angle should be at least greater or equal to this theta. Is that clear, Aryan? Are you talking about this? So E and Vm are given to you. You can calculate in this way. Okay. So what is the answer for this question? Nilmesh has given answer D. Aryan, what is your answer? Whether D is correct, you are also getting D. Let's see. So power is flowing from load to source. So again what we will be having? If power is flowing from load to source, the KVL that we will be having is minus E plus I naught R, and one thing that we are very sure is alpha must has to be greater than 90 degree. Okay. So see, this condition we will apply. Okay. So what you will get from here? V naught, this is a 3-phase full converter. So V naught formula will be 3 VML over pi cos of alpha, and minus of E means 208 plus I naught is 18, and what is the value of R? It is 0.5. Okay. So how much you will get here? 208 minus 208 plus 9. You will get minus 199 here. And 3 into VML, maximum value of the line voltage. So root 2 into the line voltage given is 230 volt. Okay. Let me use some more space. So it will be 3 into root 2 into 230 divided by 3.14 cos of alpha. This is minus 199. So alpha is the only unknown, and when you will calculate, you will get 129.8 degree. Okay, which is given in option number D. Okay, so D is correct. But in last question, E was greater than VM. Achha. I hope you got it. Okay. So this is how you will get the value of alpha in this question. Okay, and now you can see alpha what you are calculating is coming greater than 90 degree. If it is so, power will be fed from load towards the source. Okay, so which is fundamentally also correct. So 2 questions we have solved related to this when we have to apply what? KVL. Okay, so be ready for these kinds of question in the upcoming exam. Now this question. Okay, now let's see this question. A single phase full converter delivers power to a resistive load of 10 ohm for an AC source voltage of 230 volt. The RMS output current will be. You have to calculate what will be the RMS output current if the firing angle is given 45 degree. Okay, so there are a lot of confusion in this, and you know what students normally what mistake the students will commit. Let me check whether you are conceptually clear with this or not. Okay, so Aryan and Nilmesh, I am waiting for your answer for this question. We have a single phase full controlled converter operating at firing angle of 45 degree, feeding to a resistive load. Okay, then what will be the RMS current? RMS current will be RMS voltage divided by the resistance. Okay, so you have to find RMS voltage. And normally we know that in case of single phase full bridge controlled converter, RMS output voltage is equals to the source voltage. But when we can do that particular thing? Or forget about that, simply how to solve this question. Aryan, you were asking E was greater than VM. Yes, then theta value that you will get will be greater than 90 degree. Okay. So before 90 you can't choose your value of alpha. You have to choose your value of alpha after the 90. Okay. This change will be occurred. Okay. So I am not getting any answer. So what to do here? Just see. So guys, we are having sinusoidal AC voltage. Okay. Normally what load we used to get? We used to get a load of RL type or RLE type. If that load we are getting, we know the corresponding formulas for that. But those formulas are not equally applicable for resistive load. We have to calculate here. Okay. So whenever you are getting resistive load, you have to calculate the things. Okay, so just see, we are having sinusoidal voltage like this. So this is the voltage that we have, pi 2 pi. Okay, now what will be the output voltage? So when it is your positive cycle, okay, at that time T1 and T2 will be forward bias. Okay, so when T1 T2 will be forward bias, what we will be doing? If we give them gate pulse at this point of time, which is alpha here, okay, let me call this alpha and let me call this to be pi plus alpha. So if we will give them gate pulse here, they will follow the input voltage. Okay, and after pi, since we are having resistive load, negative cycle has started, immediately T1 and T2 will get reverse bias. Okay, if there would have been any inductor, they will be following the voltage. Okay, so T1 and T2 they have conducted for this duration, alpha to pi. Now at pi plus alpha, negative cycle is going on and you will trigger T3 and T4. So they will follow the input pattern again up till 2 pi. Okay, so in this duration, we will be having T3, T4 conducting. And after that, again you will trigger T1 and T2 at 2 pi plus alpha. Okay, so see, this kind of waveform we will be getting. Now in this waveform, if you see, this pattern is getting repeated again and again, isn't it? This pattern that we have is getting repeated. So what will be the time period? It will be pi. Okay, the time period will be pi. So if we calculate the RMS voltage from this waveform, what we will be getting? Under root 1 by time period. Time period is how much? Pi. Okay, and we are getting output voltage for alpha to pi on this duration, alpha to pi, and at that time your output voltage is exactly equal to input voltage, so we will integrate the input voltage by squaring it. Okay, so this is what we have to solve. Now we have a trick for solving these kinds of integral. If you want to get this, what is that trick you can use here? It will be Vm upon 2 into time period, high limit minus low limit, okay, plus half sine 2 omega t, low limit and high limit power 1 by 2. Okay, so you can use this trick to solve this integral. If you are solving this integral, it will take a lot of time. So you can use this particular trick to solve this. Now if you put the values, Vm upon under root 2 into time period, which is pi, high limit is pi, low limit is alpha, plus half sine 2 omega t, lower limit is alpha and upper limit is pi, okay, whole to the power 1 by 2. Then what you will get? We may write it Vm by root 2, which will be Vs upon under root of pi, and then pi minus alpha. When you will put the limits and solve it, you will get half of sine 2 alpha to the power 1 by 2. Okay, so this is what you will get as RMS voltage. Now put the values. What is the value of Vs we have? It is 230 volt. Okay, so 230 volt divided by 3.14 under root pi minus alpha. Alpha is given 45, means pi minus pi by 4, plus half of sine 2, here we will put in terms of degrees, okay, and whole to the power 1 by 2. Now when you will solve, you will get a value of voltage to 18.04. Okay, this will be the voltage. Once you have obtained the voltage, the RMS value of current, it will be what? The RMS value of current will be RMS value of voltage divided by the impedance, which is resistance only here. So 208 to 18.04 divided by the resistance value is how much? 10 ohm. Okay, so we will write 10 here, and what we will get? 21.8 amperes. This will be the answer, which Nilmesh has already obtained. Very good, Nilmesh. Okay. So just see, guys. Students are preparing for everything, but gate authorities, they will give you a simple case of problem. They will give you a normal resistive load. You are prepared for RL load, RLE load, but if you they will simply give you a resistive load, and you are applying the same concept, you will mistake there. You will be getting a mistake. You will be getting mistaken there. Okay. So what we have to do here, if suppose the resistive load is there, if the load is resistive, okay, always, I will always recommend you to do this analysis and calculate the voltages in this manner. Okay. Those formulas that you know, in that case you have taken RL load, RLE load. Okay. If load is only resistive, it is always preferred that you will do the analysis and then calculate the thing. Okay. Because we are done with a lot of some higher cases, but this simple case, if they will give, students are confused among them. Okay. So be ready for these kind of questions. Now next question. The three-phase fully controlled bridge converter fed from 440 volt 50 Hz AC source and is operating at a firing angle of 30 degree. Alpha is given 30 degree. The load current is assumed to be constant, okay, at 10 ampere. So current is constant at 10 ampere. Due to high load inductance, the input power factor of the converter will be, what will be the power factor of the converter? This is what you have to calculate, and this is a very important problem because gate authorities, they are really in love with two formulas related to rectifier. Okay, and they will definitely give one question from the same topic. Okay, there are two popular formulas in rectifiers related to finding the power factor, and gate authorities, they really love that particular formulas. So they will definitely give you a question. So Nilmesh already got an answer. 0.82. RN, what about you? Divya, RN, Selja, Nilmesh. Nilmesh has already got the answer. 3 by pi cos alpha. Very good. Okay. So I think everybody is giving an answer, so I don't need that. So when it is single phase, full controlled rectifier feeding a constant output current, the power factor formula that we have is 2√2 upon pi cos alpha. Okay. And when it is three phase full controlled rectifier, okay, then the power factor formula is 3 by pi cos alpha. So you only need the value of alpha to calculate the power factor, which is given in your case. Cos of, how much is alpha? 30. So when you will solve it, you will get 0.82, which is given in option number D. Okay. So just see. Either you will get a problem related to this formula or related to this formula. These two are the formulas which are very, very important for every electrical aspirant appearing in the gate exam prepared with power electronics. And gate authorities, they are very much in love with these two formulas. Okay, because if you don't know this formula, you have to do a lot of stuff to calculate the power factor. But these formulas, they generally used to make our job a little easier. Okay, so that's why these formulas are very, very important. So this we have also calculated. Now moving towards this question. So we are done with single phase converter, three phase converter. Now it is a turn to do some problem related to the effect of source inductance, another very important topic. So in single phase fully controlled bridge rectifier, the firing angle and the overlap angle are 27 and 8 degrees. Firing angle is 27 degrees, overlap angle is 8 degrees respectively. If it is feeding a constant output DC current of 20 ampere, output current is 20 ampere, then average output voltage for an input AC of 230 volt will be, you have to find the average output voltage in this case. Okay, you have to find the average output voltage in this particular case. Okay, and overlap angle is given. So when the overlap angle concept is coming, that means your source is having some inductance. Okay, so I am giving you 4 minutes for this problem, not 4 minutes, because gate only gives you 3 minutes, so I am giving you 3 minutes, because there are a lot of calculations involved here. So whenever there is an overlap angle given or being asked, there is an involvement of source inductance, okay, which is not given to you in this problem. Okay, so I leave it up to you. Invest your time in this question and tell me what is going to be the average output voltage. Okay, this is what you have to find here. So let me see whether you are aware of these formulas and concepts as well. Effect of source inductance is a very important topic from rectifier. Okay, students will definitely get questions from this particular topic. And there are a lot of calculations involved. Okay, if suppose you will get a problem related to source inductance in the exam, I will always recommend you to attempt that particular question at the very end. Okay, as per the time you are left with in the exam, because they involve a lot of calculations. They will definitely take you 3 minutes, even they can consume more minutes. Okay, so always attempt question related to source inductance at the end of the exam. See, even 3 minutes are not enough, isn't it? They are taking time. I know that if you know the concept as well and formula as well, it will take a time. It will take a lot of time for calculation. Okay. So guys, we have been given with the current. So first of all, apply the expression for current. Whether it is single phase full control or 3-phase full control, the formula of current is same. Vm upon 2 omega Ls. And in 3-phase, you will take VML, line voltage. Cos of alpha minus cos of alpha plus mu. This is the formula. Okay. Now just see, we have been given with the current, which is 20 ampere. Vm is maximum value of the voltage. So what is the voltage? 230 volts. So maximum value will be 230 root 2 divided by 2 omega Ls. Omega Ls means 2 pi f, and Ls value is not given to us. So Ls is what we have to calculate here. Cos of alpha is 27 minus alpha plus mu will be 27 plus 8. So what you can see, the only unknown thing here is the inductance. Okay. So when you will solve this expression for the value of inductance, you will get a value of 2 millihenry. Okay. You will get a value of 2 millihenry. Now why we have calculated this, it will be clear to you. So now just see, V naught average, the new V naught average, and whenever source inductance is there, there will be a net reduction in the output voltage. Okay, there will be a net reduction in the output voltage. So earlier, what was the voltage in a single phase full converter? It has to be 2 Vm by pi cos alpha. Then reduction in case of single phase full converter, it is 4f ls I naught. If it is a three phase converter, this will be 6f ls I naught. And here you will be writing 3 Vml upon pi cos alpha. Okay. Now put the values. 2 into Vm will be root 2 into 230 divided by 3.14. Cos of alpha is cos of 27 degree. Minus 4f is 50. L you have calculated is 2 into 10 to the power 3. I naught is 20 ampere. So when you will solve it, you will get around 166.57. That is the answer I am having. Okay. Volts. This will be the answer. So this is an NIT type of answer. Okay. So you will be given a range like 175.5 to 176, 175 point, or let us suppose 176 to 177. So in that range, Neelmesh, your answer is also lying. That means your answer is also correct. Okay. And you are in great touch of this subtopic as well. Very good. But I think it has taken a lot of time, and that's why I am recommending, if you get a question related to source inductance, always attempt at the end of the exam. Okay? Because they are definitely going to consume a lot of time of yours. Fine. So is that clear, guys? These are the important expressions. This current expression, it is going to remain same in three-phase converter as well. Only Vm might be replaced with VML. Output voltage expression, how you will be writing? Whenever source inductance is there, there will be a net reduction in the output voltage. So this was the old voltage. Reduction is this amount. New voltage will be reduced one. Okay. So just remember these facts. If it is a three-phase converter, you will be writing 3 VML upon pi cos alpha minus 6 FLS I naught. Okay. So this is how you can go for these questions. Now let me have another question. So a three-phase full bridge converter is connected to a supply voltage of 230 volt per phase. Do not forget this, per phase. Normally in three-phase, supply is given in terms of line quantities, but here they have given in terms of phase quantities. At a frequency of 58, the source inductance is 2 millihenry. L is 2 millihenry. Okay. And the load current at the DC side is constant at 18 ampere. Output current is constant at 18 ampere. If the load consists of a DC source of internal EMF of 380 volt, internal EMF means E, 380 volt, and internal resistance of 0.5 ohm, okay, then overlap angle will be, now you have to calculate what will be the value of overlap angle. Okay, so in the last case it was related to full converter, single phase converter. During that I have told you the formula that you have to use for three phase converter. If you are able to utilize those formula, you will be able to solve this problem. Okay, so I am giving you 3 minutes again, and I want an answer from you right now, and a correct answer, because I think we have discussed what we have to do in the last case as well. Okay, so take your time, don't be in a hurry, and don't do any mistake. I want a correct answer from you guys. The formula of current is same, okay, in case of single phase full converter or three phase full converter. Voltage expression, how you have to write? Old voltage three phase minus the reduction. Reduction will be 6 FLS I naught. With this end, you can solve this question. last 1 minute is approaching. Aryan, Nilmesh, did you get the answer? Okay. So guys, just see, we can find output voltage by using this data. V is equals to E naught plus E plus I naught R. So E is given 380 plus I naught is 18 plus R is 0.5. So you will get 389 volt as the output voltage. Now how to find the output voltage? Output voltage will be old output voltage, okay, which is 3 VML upon pi cos alpha minus the reduction factor, which is 6 FLS I naught. Okay. Now put the values here. You have this voltage as 389. 3 VML. First of all, you have to find the line voltage. Phase voltage is given 230. So in order to find line voltage, you have to multiply it with 230. So this will be your line voltage. When you will multiply with root 2, you will get the maximum value. Divided by pi. Okay. And cos of alpha minus 6 into F is 50 into LS is 2 millihenry into I naught is 18. So you can see only unknown quantity here is alpha. So when you will solve this equation, you will get the value of alpha, which will be equals to 42.26. Okay. Alpha value will be 42.26 degree. So now we have with us the value of alpha. Okay. And this is how you have to do it. Okay. Again, see, just the same analysis we are doing. Now you know that we are aware of one equation related to current, which is VML upon omega Ls cos of alpha minus cos of alpha plus mu. Now put the values here as well. I naught is given 18. VML, it will be, first of all, you have to convert 230 phase voltage into line voltage by multiplying by 3, and then you will multiply it with root 2. So you will get the maximum value of line voltage divided by omega Ls. So omega will be 2 pi F into Ls, the inductance. How much it is given? 2 millihenry. So 2 into 10 to the power minus 3 cos of alpha. Alpha just now you have calculated 42.26. 42.26 minus cos of 42.26 plus mu. So you can see only unknown thing is mu here, and when you will solve it for mu, the value of mu, that is overlap angle, is what I am having is 1.68 degrees. Okay, and to solve this equation is not an easy task. It will require a lot of time. Okay, you have to invest a lot of time while solving these equations. So although the concept is easy, very restricted amount of formulas we have to use, and we can make ourselves very much familiar about the formulas, but still the calculations required are very much what we can say, calculations requires are too much. So that is why I am recommending you to solve the questions related to the source inductance at the end of the exam, if you have sufficient time. Okay, otherwise they can waste your time as well. Fine, but there is a surety that you will get a question related to these in the exam. Okay, so these two questions If you will prepare well, you are almost prepared for the topic. Now focus on this question. A single phase full control bridge converter operates in continuous conduction mode from 320 volt 50 Hz single phase supply. With a firing angle of 45 degree, the load resistance is 10 ohm and large inductance. The ratio of fifth harmonic component to the fundamental source current will be what? So you have to find the ratio of fifth harmonic component to the fundamental harmonic component. This is what you have to calculate in this question. And your time starts now. I can देखिए this is an easy question and you can solve it. I'm waiting for your replies. This is an easy question because you have solved so many difficult questions. So if you are able to solve those questions, this one is a very easy one and you can pretty easily solve this question. Nilmesh is saying answer is B. Yes, Nilmesh, B is the correct answer. You are listening me very carefully, isn't it? Because at one place during the inverter, I have told you about the same. Whenever you have to find the ratio of any component with respect to the fundamental component, answer will be 1 by n. Okay, 1 by 5. That means 20%. So don't waste your time in such a questions. Okay, so what we have to do? The source current Fourier series. What is it? N equals to 1, 3, 5 to infinite 4 I naught upon n pi sine of n omega t plus phi n. Okay. Now from here, if you will calculate the fifth component to the fundamental component ratio, you will be getting 4 I naught upon 5 pi upon 4 I naught upon pi, and you will get 1 by 5, that means 20%. So you don't have to waste your time, isn't it? Whenever you have to calculate the ratio of any component with respect to the fundamental, it will be 1 upon n. Okay, provided that your expression is like this, where you are only having this component. If suppose something else is written, cos n theta, cos n pi by 6, in that case it is not valid. Okay, you have to be very careful. In that case it is not valid, you have to calculate. Okay, so I hope you got this question as well. Okay, so this question I have just given to utilize whether you have the concept that you are listening me carefully or not. So next question, and this is very important and very conceptual question. Just see, a single phase, and this is going to be the last question of the day as well. A single phase half control converter is connected to RL load. So we have RL load. Let me make the load. We have R and L load. Okay, so this is the load that we are having. If the load carries a constant DC current of 20 ampere, okay, load current of 20 ampere, I naught is constant. The average current through the diode D1 will be, we have to find what will be the average current across the diode D1. Okay, consider the converter is operating at a firing angle of 45 degree. Okay, so let me see whether students you can solve this question, and I am giving you 3 minutes for it. Okay, you can take your time because it is a very conceptual question. You have to find the average value of current across diode 1. In exam you may get diode 2 as well. Okay, they may connect different configuration. They may replace this diode with thyristor as well. So they can do anything, but the concept remains same. Okay, and if they have to make a difficult question from rectifier, they will definitely do this fumble. Okay, they may replace the switches. They may give you 3 thyristor, 1 diode, 3 diode, 1 thyristor. Like that scenario, they will be changing. Okay, because they can't do anything else apart from this. Wow, excellent Nilmesh, fantastic, proud of you. 12.5. If you are able to solve this question, I do believe that you can solve any question in the GATE exam. Very good. So just see what we'll be doing here. Okay, let me plot a sine wave first of all. So this is my sine wave. Okay, and then let me plot what I have to calculate here is output. Let me plot the output voltage first of all, and I will be plotting current as well here, and then I will be talking about diode current. Okay, so these will be my instant. Here I have alpha. Okay, then this will be pi, then this will be pi plus alpha, then this will be 2 pi. Similarly, I will be having something here which is 2 pi plus alpha. Okay, now when we are at the positive cycle, just see. So when we will be having positive cycle here, so during the positive cycle, T1 and D1, they will be forward bias, and inductor, it will be having a polarity like this at the beginning. Okay, and it will be storing the energy, and output will be exactly equal to the input. Okay, so what will happen? The output will follow the input waveform. And who is conducting? T1 and D2. T1 and D2, they are conducting. Okay, when you will reach up to this point, negative cycle starts. So when the negative cycle will start, D2 must have become reverse bias. So what will happen? The inductor current should have become suddenly 0, but inductor cannot resist that the current across it is changing suddenly. So what it will do? It will reverse its polarity. Okay, so this will be the polarity at the end of the cycle. So what will happen? Due to this polarity, we will be having D1 and D2 conducting. So what energy inductor has stored during T1 and D2, now it will be releasing this energy. So what will happen? During this moment, we will be having D1, D2 conducting. Okay, we will be having D1, D2 conducting during this moment, and T1, D2, they have conducted up till this moment. Now next time what will happen? Now we are at pi plus alpha, negative cycle is going on. So during the negative cycle, when we are having this polarity, okay, due to this polarity, D1 and T2, they will be forward bias, and they will be again storing the energy across the inductor with this polarity. So output will be equals to input, and output will be following the input like this. Okay, now when you will reach at 2 pi, again positive cycle is coming. So if positive cycle will come, okay, So what happens? T2 must have become reverse bias. So there will not be any path for the current to flow. But inductor has stored energy which has to release. So it will reverse its polarity and D2 will become forward bias. So D1, D2 will now freewheel the inductor energy. So again what will happen? Again we will be having here D1, D2 which will be conducting. Okay. So again just see D1 and D2 they are conducting. Here which switch has conducted? T2 and D1. Similarly we can write here that D1 and D2 are conducting following this scenario. So this is this is alpha, this is pi plus alpha, not only pi plus alpha, this is pi. So this is pi plus alpha, this is 2 pi and this is 2 pi plus alpha. Okay. And what about the output current? Output current is maintained constant throughout. Okay, this is what they are saying. So output current is maintained constant throughout with magnitude of I naught. Now we have to find the diode 1 current. So just see when diode D1 is conducting. Diode D1 is conducting here as well. Okay, let me use other color. So diode D1 it is on here and at that time it might be having exactly equal current I naught. Okay, this is alpha. Then D1 starts conducting from here. Okay, just see. After that D1 is not conducting, we will get zero current. Then D1 starts conducting from here and it conducts up till this duration. Okay, and then again it will be not conducting. So just see, this is alpha, this is pi plus alpha, this is 2 pi and this is 2 pi plus alpha. Okay, this is what we are having here. So now if I ask you, in a 2 pi cycle, for what duration our diode D1 is conducting, then what will be your answer? In a 2 pi cycle, for what duration we are having D1 conducting? In a 2 pi cycle, okay, just see. So in a 2 pi cycle, D1 is conducting for pi plus alpha, yes or no? Isn't it? Just see. So D1 conducts for I can write 2 pi plus alpha minus pi, isn't it? So what I will get? I will get pi plus alpha. Now if I have to calculate ID1 average, okay, so this will be having a magnitude I naught and it is available for pi plus alpha out of total 2 pi duration available for conduction. So this will be my ID1 average. Now what is I naught? 20. Okay, so I naught is 20. Pi plus alpha is given pi by 4 divided by 2 pi. When you will do this, you will get 20.5 ampere as the answer. Okay. Similarly, instead of D1, they may ask you for D2. So D2 waveform you only have to trace. Okay, you have to trace only D2 waveform. And similarly, answer will be same. Whether it is D1 or D2, answer will be same. Now they may ask you the ratio of them. It will be 1. Okay. So be ready for these kind of questions. So this is the end of the session today. Okay. Now on power electronics, I have taken 2 sessions. One yesterday and the second which you are attending right now. Okay. Guys, together in these 2 sessions, we have discussed almost 50 plus questions. 50 plus questions with some excellent concepts and tricks. And some of them are the probable gate question. You will see questions like this in the upcoming exam. So follow these 2 sessions, practice these questions as much as you can, and this is how you can make yourself well prepared for the upcoming gate exam. So I hope that you people have really liked this session, you have enjoyed this session, and you also have felt that power electronics can be manageable, isn't it? Power electronics is a kind of subject which we can manage well in the exam. Okay, very good. Thank you, Nilmesh. Okay, power electronics is a kind of subject which require conceptual and fundamental clarity, which while solving the questions I have tried my level best to give you. So practice these 50 questions, and this year, my personal guess is this year, power electronics is going to give you a lot of questions. It will go to what its average peak is. So average marks of power electronics in GATE exam is around 11 to 13 marks. Last year it has given only 6 marks of questions. So this year it is going to be the paper of power electronics. You will see a lot of questions from power electronics. So prepare these 50 questions and you will get the same flavor in the upcoming GATE exam. And this is how you can prepare yourself very well for the power electronics. Okay. So thank you so much for attending this session. If you really have liked what we have discussed here and the teaching and learning methodology of IMS GATE Academy, you can join this Telegram channel through this link which is given in the description box to get a regular updates on seminar, webinar, GATE and PSU exams, and to get the PDF of the session. Okay. And also, if you wish to join, if you want to enjoy this teaching learning methodology more and more, you can join IMS GATE Academy live online program, which will offer you 800 plus live hours of teaching. We will give you theory book, exercise book, which contains 4,000 questions, GATE question banks, which contains almost 3,500 questions, and 130 plus online test series which contains 130 plus test, which includes 3,000 questions. So if you are prepared with these 7,000 questions, you can just qualify any exam of the world. Okay, so this is what we are offering here at IMS GATE Academy. You can join and you can start your preparation journey with IMS GATE Academy, and you can write your success story with IMS GATE Academy. Okay, we have written so many success stories. You can be the next one as well. You can join. You can book a free counseling session by calling on any of these numbers. Okay, so I'm signing off from today's session. I hope you people have enjoyed a lot this session, and this session is going to help you in specifically in preparation of power electronics. Okay, so thank you guys. Thank you so much. Best of luck for the upcoming exam. Now, I will meet you on 26th and 27th of December with the subject power system in GATE score booster series again. So thank you so much for attending this session. Thank you.